Hi ladies and gentlemen, this is SU Manzi from CWH Academy. We are doing home and online tutoring services. So we focus on the following subjects, that is mathematics, life science and physical science. So from grade 9 to grade 12. So we also do Saturday lessons. So we do Saturday classes. So we take our students and then we do a session from 9 o'clock to 12 o'clock. And then we also have the special program called WhatsApp Homework Tutorial Assistant. So it's a student or a learner will send an expression or a challenge or any exercise, and then we try to come with the solution of that, and then we explain step by step, and then we send to the student, and then we interact via WhatsApp. And then, as I said, we focus on Saturday classes, and then we've got another special session where we do what you call the mobile tutoring. So we go to your house, so the parent will book a slot from CWH Academy, and then we go to your house, and then we teach your learner or your student or your child in a conducive environment. And then the student can even come to our classes where we do Saturday classes. And then we focus on weekends, holidays, and after school. And then we do personalized or one-on-one sessions. And then we ask the student into their homeworks, assignments, and then we also do exam revision, especially in PEPs. So we also give a privilege to student to book their, for instance, we can book any topic from physics, life sciences, and also in physical sciences. So we book an expression or a challenge or any exercise, and then we resolve that. We resolve or we come with solutions, and then step by step we explain to the student, and then we narrate each and every step of that challenge. But today we are going to focus on mathematics. So we're going to talk about exponents in grade 11 to grade 12. So for this expression, so we focus on expressions in exponent that are having numerical values. So we're going to solve expressions that are having numerical values. So let's solve this one. Okay, before you solve, we look at the expression, especially when those expressions with numerical values. You look and then ensure that all the bases are put, or you make it all the bases to be in a form of exponential form. Yeah, you put it in an exponential form. Okay, let's do this one. Let's solve, or let's simplify this one. Okay, so we've got 4 to the power n plus 2 times 9 to the power n minus 1 divided by 72 to the power n times 2 to the power 1 minus 10. So we're simplifying this one. 4, it will be 2 to the power 2. Close the brackets, and then we're going to forget our exponents. N plus 2, and then we put 9 in an exponential form, which will be 3 to the power 2. Close the brackets, and minus 1, this one. And then we divide by 72. Okay, let's work on 72. 72, it would be 72 is equal to 2 times 36. 72 will be 2 times 6 times 6. 72 will be 2 times 2 times 3 times 2 times 3. 72 will be 2 to the power 2. So to the power 3, sorry, times 3 to the power 2. This one is 8. This one is 9. So if you multiply, we've got 72. So we're going to utilize this one in an exponential form. So we've got power 72 will be 3 to the power 2 times 2 to the power 3. We close the bracket, and then we put this n, is times, we write it as it is, 2 to the power 1 minus n. Okay. Or let's clean this area so that we can utilize the space here. Right, we utilize the space. Utilize the space here. Right. Okay. Now, if you look at this now, we see that there are a lot of brackets. So especially in algebra, we utilize this principle of mathematics. So we're going to open the brackets. We start with brackets of division, multiplication, addition, and subtraction. So now before we go to division, multiplication, we start with brackets. So let's open the brackets. Now numerator. So we write 2, the base 2 times 2. 2 times n is 2n. 2 times 2 is plus 4. And then we come to this one here. 3, we write the base times 3. Okay, let's write 2 times 3 like this here so that we can see it. And then 2 times n is 2n. 2 times minus 1 is 2. And then we divide by, we also open the brackets here. It's 3 times. So it's 2 times n, it's 2n. And then we have the 2 as a base, and 3 times n is 3n. And then times 2. These dots means times. So 1 minus n, this one. So write it as it is. Now we look, okay, we find that okay, the bases are the same. This base is the same, this one. This base is the same, this one. This base is the same, this one. But before we, as we know in exponents, in a division, we subtract all the powers that are in the numerator. But before we subtract, let's look, we've got like terms here. So 3n, 1 minus n. So these are the like terms, the bases are the same. So let's work on these like terms. Okay? So we're going to write this expression as it is, 2 to the power 2n plus 4 times 3 to the power 2n minus 2 divide by, and then we said there are like terms, this one and this one is a like term. So we're going to write 3 to the power 2n as it is times 2. We like to take one base here because the bases are the same, 2. And then 3n minus n, which will be 2n plus 1. Okay, let's write it here. Let's continue here. So we have 2 as a base to the power 2n plus 4. And then times 3 to the power 2n minus 2. It's minus 2 years. And then underneath, meaning that divide, underneath in our numerator, we've got 3 to the power 2n times 2 to the power 2n plus 1. Okay. Now at this stage, you can see this one, this base is the same like this one, and this one is the same like this one. So if the bases are the same in a division, in exponents, we ensure that we separate all the bases that are on the denominator to those ones of the numerator. How to do that? Okay, let's do like this. So we're going to write this one will separate this one. This power will separate these powers. This exponent will separate this exponent. This one will separate this one. This one will separate these ones. Okay? So we've got 2 to the power 2n plus 4. And then minus, and put in bracket. So because the bases are the same. So it's 2n plus 1. And then times 3 to the power 2n minus 2. And then the bases we said are the same. Minus these 2n as a power, minus into bracket. bracket, 2n, close the bracket. Now at this stage, you can see that we collect the like terms here. So we write the base, it's 2, this one, and then 2 minus 2n, this one cancel with left 0, 4 minus 1 is 3 times, we write the bases it is, and then we collect the like terms here. 2 minus 2n, this one cancel left with 0, and then we're left with 3 to the power minus 2. So we're left with 3 to the power minus 2. We're trying to make it simple. As we said, we are simplifying. Okay, now here. So 2 to the power 3 is 8, meaning that we are going to say 2 times 2 is 4. 4 times 2 is 8. That is, multiply 2 by itself 3 times. And then here, 3 to the power minus 2. You see, there is a minus. So if there is a minus, we write in a simple way by putting a division. That is the law of exponents. Once there is a minus, we put an exponent in a division form. So this one, it will be 1 over 3 to the power 2. This is the same thing in exponents. It's a law of exponents. So 1 over 3 to the power 2 is the same thing. This thing is the same. Alright, now our final answer is, okay, before we go to our final answer, so 8 times 1 is 8 over 3 to the power 2. So 3 to the power 2 means that we multiply 3 by itself, 3 times 3 is 9. So the final answer is 8 over 9. That is, it's an expression where you find that bases and numbers. So we're solving bases we're simplifying bases that are numerical. So we call it numerical bases. So we're solving exponents with numerical bases. Like here we said 4 to the power n minus plus 2 here. Plus 2. So the base, this is the base. This is the base. This is an exponent or power. So we're solving a problem with a power, with a base, which is a number. So this is the final answer. Thank you. You are free to ask any questions. Okay, thanks.